You know, every single time you click Buy Now, you're kicking off this incredibly complex, high-speed ballet that you never even get to see. Deep inside these massive automated warehouses, thousands of robots are performing an intricate dance, all to get your package to you on time. Today, we're going to pull back the curtain on the AI choreographer that's teaching them all the steps.
Okay, so take a look at this. It might look like some kind of retro video game, but this is a map of a very real, very busy warehouse floor. Every single one of those little squares is a potential stop, and trying to navigate this grid is a huge, huge challenge. This is the dance floor we're talking about, and the performance, it has to be absolutely perfect, 24/7.
So, what's the big deal here? Well, it all comes down to scale. We're talking about a massive number of packages, and every single one has a different and often super urgent delivery deadline. Getting this whole symphony to play in tune without a single missed note is honestly one of the biggest problems in modern logistics.
So, who are the musicians in our symphony? Well, meet the automated guided vehicles, or AGVs for short. These little guys are the tireless workhorses of the warehouse. Their job sounds pretty simple, right? Just pick up a package and take it where it needs to go. But when you have thousands of them zipping around, simple gets really complicated really fast. And that really gets to the heart of the problem, right? How do you coordinate all of that movement? How do you get thousands of these AGVs to navigate that grid, pick up the right packages, and deliver them on time, all without causing the world's most expensive and inefficient traffic jam? That is the billion-dollar question. Now, to really appreciate this new solution, you gotta understand why the old ways of doing things just weren't cutting it. See, previous attempts to solve this whole thing were flawed because they treated it as two completely separate problems, managed by two separate brains, which it turns out is a really bad idea. So on one hand, you had packet assignment. This brain's only job was to figure out which package an AGV should go grab next. It completely ignored whether the path to get there was, totally blocked by 100 other robots. Then, on the other hand, you had path optimization. This brain was obsessed with finding the absolute shortest route, but it couldn't care less if the package it was carrying was for next day delivery or next week delivery. Neither one was seeing the whole picture. And the result of that? Well, it's kind of like two dancers trying to occupy the exact same spot on the floor at the exact same time. It's a disaster. When the part of the brain choosing the package isn't talking to the part of the brain choosing the path, you just get chaos. You get collisions, you get delays, and you get missed deadlines. So what's the solution? It's actually pretty simple in concept. You get rid of the two separate, dumb brains, and you introduce one unified, much smarter brain for the entire robot fleet. So let's meet our AI choreographer. Okay, now the official name is a bit of a mouthful. Hierarchical Transformer Reinforcement Learning, or HTRL. But the key idea behind it is actually pretty simple. It jointly optimizes both decisions at the same time. It doesn't pick a package and then find a path. No, it thinks about both problems together to find the absolute best overall solution for the entire system. So, how is this AI brain actually put together? Well, it's surprisingly elegant. You've got one encoder, that's basically its eyes, and it's constantly watching the entire dance floor. The whole warehouse. Then you've got two decoders, and they act like the choreographer's voice, telling every single robot the next two critical moves it needs to make. And these two moves, that's where the magic really happens. They have one single, unified goal: get the most urgent packages delivered as efficiently as possible. And it does that by teaching the entire fleet of robots how to think and move as a team, cooperatively. The choreographer uses this really clever two-step technique. First, the AI looks at all the packages out there and helps the robot choose the most important one based on its deadline. Then, and this is the genius part, it helps create a path that not only gets to that package quickly, but also works in harmony with the paths of all the other robots. And it's pretty fascinating to see how the AI actually sees the world. On the left, that's the real physical warehouse, but to the AGV, its immediate surroundings, what they call its field of view, gets translated into this simple binary matrix on the right. A 1 just means a space is taken by another AGV, and a 0 means it's free. It's this super simplified data that allows for lightning-fast decision-making. But here's the thing. This AI does way more than just see what's happening right now. Its real secret weapon is its ability to see into the future, to predict traffic jams before they ever happen and actively stop them.
It does this by predicting what the paper calls future spatio-temporal states. Look, that's just a fancy way of saying it calculates where every single robot will be, that's the spatio or space part, at every future moment, that's the temporal or time part. It's like a chess grandmaster thinking 10 moves ahead for every single piece on the board, all at the same time. So, what does it do with this amazing ability to see the future? It uses something called Model Predictive Control, or MPC. Now, instead of that old, clunky stop-and-wait method where a robot just slams on the brakes to avoid a crash, MPC lets the AI subtly adjust each robot's speed. It's the difference between a jerky commute full of sudden stops and a perfectly synchronized, flowing dance. Okay, so the theory is impressive. The AI is smarter, it sees the future, it makes the whole dance more graceful. But does this fancy new choreography actually lead to a better performance? Let's put it to the test and look at the results. This is really the moment of truth, isn't it? After all this complex AI and predictive modeling, does it actually get more packages delivered on time? The answer is a huge, resounding yes. The HTRL framework led to a 36.6% increase in on-time package deliveries. Now, in the world of logistics, an improvement of just a few percent is a big deal. 36%? That's not an improvement, that's a revolution. And, just look at this chart to see how massive that leap really is. The HTRL framework nailed it, successfully delivering 90% of packages on time. Now compare that to other advanced learning-based methods, which are down at 70%, or simple rule-based systems struggling at 60%. The AI choreographer isn't just a little better, it's playing in a completely different league. The researcher's own conclusion really says it all. This framework just flat out works. It gives the entire fleet of robots the power to make smart, efficient decisions that guarantee deadlines get met, even when you're dealing with a massive number of packages. It solves that core problem we started with, the robotic traffic jam. So why does all this techie stuff matter to you? Well, it's simple. This hidden robotic dance, now perfected by an AI choreographer, is the reason the stuff you buy online shows up at your door faster and more reliably than ever before. This is the quiet revolution that makes modern e-commerce possible. And that leaves us with a pretty fascinating thought, doesn't it? This is about so much more than just warehouses. This is about teaching cooperation and foresight to a complex system of independent agents. So, if AI can perfect the robot dance, what complex human system will it learn to choreograph next? Citywide traffic? Global supply chains? The dance is really just beginning.